Previous video we talked about indefinite integrals and how we can get indefinite integral, and that's the antiderivative of a function. So let's go back to an example. Let's say we've got a quadratic equation and we want to get the derivative of this function. So let's say we've got this function, we get the derivative, so we need to differentiate. 3, to do that, remember we multiplied the power with the coefficient, so that's going to be 15x squared plus 2, and constants is always 0. So now a question might be that we've got a specific derivative, so we've got the derivative of a function, and now we want to go back to the original function. So remember, there's always a constant here at the back that we don't know about. And to get back to the original function, we have to get the antiderivative of the solution here. So if we do an antiderivative of a derivative, that will give us the original function. Okay, so to get back from here to the original function, we have to do the integral of that function. So let's go to the integral of 15x squared plus 2 dx. And to get the integral, we add 1 to the power and then we divide by the power. 2, we just add an x if we do the integral, and it's going to be plus c. So this will be the answer of our function. But note that we don't know what the x is, or the constant is. So normally when you need to get the function, they always need to give you more information. So they'll say that this function fx goes through a point, let's say 1, 2. So now, after you've done the antiderivative, now we can substitute the x value and the function value, fx, or the y value, into the function. So we're going to say 2 is equal to 5x to the power of 3 plus, instead of x, remember x we're going to substitute with 1, so it's going to be x1 to the power of 3 plus 2 multiplied by 1 plus c. So you'll see the x values we substitute with 2, and the y value we substitute, the x value we substitute with 1, and the y value with 2. Then we just solve this equation. So we say this is then going to be, let's write it to this side, it's going to be 2 is equal to 5 plus 2 plus c. So c will be equal to minus 5. So in this case, if it goes through the point 1, 2, the function would be the answer that we got here, which is 5x to the power of 3 plus 2x minus 5. So let's take another example. We've got now they give you the antiderivative, so we're going to say we've got an antiderivative of a function which is 8x minus 5, and it goes through a point 0, 1. So to get the original function, we have to get the antiderivative, or the integral, of 8x minus 5. And we're going to substitute or do the integral. So that's going to be x squared minus 5x plus a constant. So this will be our function. Now we substitute the x and the y values. So this is the x and that's the y. So 1 is going to be 8 times 0 minus 5 times 0 plus c. So c will be equal to 1. So our final answer will be 5 is 8x squared minus 5x plus 1. And that's how you get a specific function using integrals and a specific point.